Hello everyone, I am Dr. Sudhan Sharma from School of Computer and Information Science in Indira Gandhi National Open University, and in today's session is about understanding quadratic equation. In our previous sessions, we had already discussed about complex numbers, and that is the part of algebra 2, and the subsequent unit in this block, that is algebra 2, is our quadratic equations. Before exploring the quadratic equation in more details, let's firstly understand what quadratic equations are. In fact, in our earlier sessions, we learned about what linear equations are. The equations in which the variables whose power is 1 are considered the linear equation, and they are having single solution because the power of the variable, say x, is 1. But in case if the power of the variable, exponential power of the variable, say x is x square, say we are having ax square plus bx plus c. Now the maximum power is 2. Such type of equations are referred as quadratic equations, and they are having two solutions because the power is 2. Now in order to understand it in more details, let's firstly begin with what quadratic equations are. To begin with, the session objectives of today's session are to understand the quadratic equations, determine the solutions of the quadratic equations, and apply the quadratic formula. Now, as I already said that quadratic equation is an equation that can be written in the form ax square plus bx plus c equal to 0 is nothing but a quadratic equation. Apart from this, we need to understand that the coefficient with the coefficient a, b and c are there, where c is a constant, b is the coefficient of x, c and a is the coefficient of x square. Now a should not be equal to 0. If a is equal to 0, then the equation will transform to bx plus c equal to 0, which is a linear equation. Why linear equation? As I already said, because the maximum power of x is 1, so that transforms into a linear equation. So what is the primary requirement is that maximum power of x should be 2 and the coefficient of x square should not be equal to 0. So a, b, c are the real numbers, and this form of ax square plus bx plus c is nothing but the standard form for a quadratic equation. Now there is a formula which is called the quadratic formula, and the formula is nothing but if we are having a quadratic equation ax square plus bx plus c where a is not equal to 0, then there could be two solutions because the maximum power of x is 2. So that means the number of solutions are to be 2. So one solution is minus b plus square root of b square minus 4ac upon 2a, and second solution is minus b minus square root of b square minus 4ac upon 2a. That means overall the two solutions can be combined into the form x is equal to minus b plus minus b square minus 4ac upon 2a, and this formula is nothing but the quadratic formula, wherein we can substitute the coefficients of the quadratic equation ax square plus bx plus c equal to 0, that is a, b and c are to be substituted into this formula to get the respective roots of the quadratic equation. Now there are actually some steps of computing the quadratic formula, but before understanding those steps, let's understand what is the formal definition of a quadratic formula. Now quadratic formula, the definition says that it is a method of completing the squares to obtain a formula for the roots of quadratic equation. Now what are those steps? That is, what are the steps for completing the squares? The first step is write an equivalent equation with only the x squared terms and the x terms on the left side of the equation. The coefficient of x squared term must be 1. The second step is add the square of 1/2 of the coefficient of the x term to the both sides of the equation. And third step is express the left side of the equation as a perfect square. Finally, we solve for x and we get the roots. What it actually means is you will better understand when we are going to solve this theorem, that if we are given a quadratic equation ax square plus bx plus c, then the roots of the equation are given by minus b plus b square minus 4ac upon 2a and minus b square minus 4ac upon 2a. For the sake of simplicity, the steps are listed over here onto the right hand side of this page and the proof is given over here, and we will discuss the proof in resonance with these steps. First, the equation given to you is ax square plus bx plus c equal to 0. Rearranging the equation, that means dividing the entire equation by a, what you will get? You will get x square plus b by a plus c by a is equal to 0. Why we did this? Because the coefficient, what is written in the first step, the coefficient of x square must be x square term must be 1. So now the coefficient of term x square is 1. So the second step is apart from this, the second step is add the square of 1/2 of the coefficient of x term. Now what is the coefficient of x term? Is b by a. So 1/2 of the x term is added onto the left hand side and the right hand side. So 1/2 of the b by a square is added on to the left hand side and right hand side. So so step 2 is complete. So after this, when we are going to solve it, now b by a into 2a whole square will turn out to be b square by 4a square. So the new equation is x square plus b by ax plus b square by 4a square is equal to minus c by a plus b square by 4a square. Now we know that x square plus b by a x plus b square by 4a square is nothing but x plus b by 2a whole square. Why? Because we know that x plus b by 2a whole square will be equal to x square plus b by 2a whole square plus 2x into b by 2a. So that means this is nothing but x square plus b square by 4a square plus b by ax, and this equation is nothing but this equation, which is in our case is nothing but the left hand side of this equation. So substituting this into the left hand side of the equation, we will get this expression. On the same lines, solving the right hand side of this equation, taking the LCM and solving it, what we will get is b square minus 4ac upon 4a square. Now again, since this equation, referring to this equation, it is into square format. So dividing the power, or taking the square root of the entire equation, what we will get is x plus b by a plus minus square root of b square minus 4ac upon 2a. Now that means there are two solutions, x plus b by 2a, and on the right hand side, when positive sign is already considered, then we will be having b square minus 4ac upon 2a. Apart from this, when we will be considering the negative sign, then we will be having the solution x plus b by a minus square root of b square minus 4ac upon 2a. So we solved for x and we get the two answers, and these two answers are nothing but the roots of the quadratic equation ax square plus bx plus c equal to 0. And this is nothing but your quadratic formula. I hope you understood that what we did. The steps were that firstly we are supposed to make the coefficient of the term x square to be 1. So the very first steps is very much clear, and this is what we did in the proof, and we followed that we write an equivalent equation, only the x square term and the x term on the left hand side, and that's why we had left only x square term and x term onto the left hand side, and the constant is passed on over here, and the coefficient of the x square term is made 1. Yes, we divided by a and get the coefficient of x square to be 1. Now after that we perform the second step, that is add the square of 1/2 of the coefficient of x term. What is the coefficient of x term? Is b by a, and 1/2 of the coefficient of x square, 1/2 of the coefficient of x term is added on the both sides, and this is added on the both sides. And then we solved and we got the quadratic formula. I hope you understood that how we got the quadratic formula. Now, this quadratic formula is carrying a lot of information, because this is in fact representing two roots, and in general the two roots are represented by alpha and beta, wherein the alpha is taking care of the positive sign of b square minus 4ac upon 2a, and beta is taking care of the negative sign of b square minus 4ac upon 2a. Now, the term b square minus 4ac, this is known as a discriminant and is referred by d, that is d is equal to b square minus 4ac, and by looking at the discriminant value, which could be either equal to 0 or greater than 0 or less than 0, we can identify that what type of roots are there. Likewise, in case 1, when b square minus 4ac is equal to 0, that means alpha is equal to beta, and the equation will have only one real root. Similarly, when b square minus 4ac is greater than 0, then alpha and beta will be distinct real numbers, and the equation will have two unequal real roots. So, in case greater than 0, two roots will be there and they are real and unequal. In case b square minus 4ac is greater than 0, then alpha is equal to beta and equation will have one root. Similarly, when b square minus 4ac is less than 0, then the alpha and beta will be two distinct complex numbers, because we learned in the complex numbers that the square root of a negative number is nothing but iota. So, because b square minus 4ac is less than 0, so that will be a negative number, that is why the roots will be complex numbers, and there will be no real roots, there will be only complex roots. So, the real roots exist when b square minus 4ac is greater than 0, and when b square minus 4ac is equal to 0. When b square minus 4ac is less than 0, then only complex root exists and there are no real roots. Now, let us extend our discussion that can we derive a quadratic equation if we are available with the roots of the equation. In order to perform this, in order to derive a quadratic equation if the roots are available, we need to understand the concept that is about the sum and the products of the roots. So, if alpha and beta are the roots, then alpha plus beta will be given by, this is the positive, taking care of the positive component, and this is taking care of the negative component. This is the negative component, this is the positive component of b square minus 4ac, and by performing the normal algebraic operation, you will find that by taking LCM 2a and performing all the operations, you will find that this and this will cancel out, as a result of which the overall solution turns out to be minus 2b upon 2a, wherein 2 and 2 also cancels out and it is minus b upon a. So, sum of the roots alpha plus beta is turned nothing but minus b upon a, where b and a are the coefficients of the quadratic equation ax square plus bx plus c equal to 0. That is, b is the coefficient of x and a is the coefficient of x square. On the same lines, if we multiply the two roots, the alpha and beta, which are nothing but minus b plus b square minus 4ac upon 2a minus b square minus 4ac upon 2a, then by performing the solution, by multiplying these two terms, because we are having identity a plus b into a minus b is equal to a square minus b square. Applying this identity onto this expression, you will get this as the result. That is minus b upon 2a whole square minus square root of b square minus 4ac upon 2a whole square. Now, because of the square root part will be vanished, as a result of which this equation get transformed into this format. So, simplifying this, that is b square minus 4a, the minus of b square upon 2a is transformed into b square upon 4a. Similarly, square root will be cancelled. So, this second expression will be b square minus 4ac upon 4a square. Now again simplifying by taking LCM, that is 4a square, and performing the normal algebraic operation, the b square part will be cancelled, and since negative sign is outside, the resulting term will be positive. As a result of which we are getting the expression 4ac upon 4a square, wherein 4a will be cancelled with 4a, as a result of which the final outcome is c by a. So that means the product of the roots is turning out to be c by a, where c is the constant term of the quadratic equation ax square plus bx plus c, and a is the coefficient of x square. So that is, if alpha and beta are the roots of the quadratic equation ax square plus bx plus c equal to 0, then alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. I hope you understood what is the role they are going to play in the understanding of quadratic equation. We are doing this to that means we are determining the sum and product of the roots, so as to understand that can we derive a quadratic equation if we know the roots of the quadratic equation. So this is how we can form a quadratic equation. So say ax square plus bx plus c is equal to 0 is the general format of a quadratic equation. Then the quadratic equation, if alpha and beta are known, but the quadratic equation is not known. The quadratic equation ax square plus bx plus c is not known. What is this equation? But we know what is alpha and what is beta. Then the quadratic equation can be produced by following this entity, that is x square minus sum of roots into x plus product of roots will be the quadratic equation. That means x square minus alpha plus beta x plus alpha beta equal to 0 will be the quadratic equation, wherein alpha plus beta is minus b by a. Substituting this minus b by a over here, and alpha beta is equal to c by a is equal to c by a over here, what you will get, because there is already a minus sign, there is already a minus sign, so minus and minus will return to plus. So as a result of which the quadratic equation will be x square plus b by ax plus c by a. And taking the LCM, we can bring this equation into the standard form, that is ax square plus bx plus c equal to 0. I hope you understood that what is the importance of calculating the sum of roots and the product of roots, because their contribution leads to the generation of the quadratic equation. So let's apply the understanding to solve few numericals. Here is an example wherein it is given that if alpha and beta are the roots of the equation ax square plus bx plus c is equal to 0 and a is not equal to 0, then we are supposed to find the value of 1 over alpha plus beta, alpha square plus beta square, alpha by beta plus beta by alpha, and finally alpha cube by alpha cube plus beta cube. Let's proceed in a one by one manner. Since alpha and beta are the roots of ax square plus bx plus c equal to 0, so that means alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. So let's solve the first task, 1 over alpha plus 1 over beta. Simplifying by taking LCM, you will get alpha beta into beta plus alpha. Now beta plus alpha is minus b by a, so putting minus b by a over here, and alpha beta is equal to c by a, so substituting it over here, and solving, the a part will be cancelled, so final answer will be minus b by c. So 1 by alpha plus 1 by beta turns out to be minus b by c. Similarly, let's go for the next part, alpha square plus beta square. Such type of questions are very much asked in the continuous evaluation, in the term and examinations also. You need to practicize it. You just need to remember the identities and apply them. Over here, we are applying the identity a plus b whole square is equal to a square plus b square plus 2ab. 2ab. This implies a square plus b square is equal to a plus b whole square minus 2ab. So, using this identity for this expression, you can say alpha plus beta square minus 2 alpha beta. And you know that alpha plus beta is nothing but minus b by a, alpha plus beta is nothing but minus b by a, and alpha beta is nothing but c by a. Substituting the values minus b by a and c by a in this expressions, you will get the answer, and solving it, you will get the answer b square minus 2ac upon a square. I think this is very simple. Now, on the same lines, let us extend our discussion to the third part, wherein we are supposed to evaluate alpha by beta plus beta by alpha. Taking the LCM, solving the entire entity, we will get alpha square plus beta square upon alpha beta. Now, in the past question, alpha square plus beta square is already evaluated, and this turns out to be b square minus 2ac upon a square. So, substituting for this, we will get this expression, and we already know alpha beta is c by a. So, inverse of c by a will be a by c, because alpha beta is appearing in denominator. Now, by solving, a will be cancelling this part. So, you will be getting b square minus 2ac upon a into c. On the same lines of action, let us solve the fourth task given to us, wherein alpha cube plus beta cube is to be determined. Now, again we are applying the entity like this, wherein we applied the formula a plus b square is equal to a square plus b square plus 2ab. Now, recalling a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. Applying this identity into this formula, you will get, in place of a just replaced by alpha, in place of b just replaced by beta. You will get alpha plus beta cube minus 3 alpha beta into alpha plus beta. Now, what is alpha plus beta? Alpha plus beta is minus b by a, we already know minus b by a, and alpha beta is c by a. So, substituting alpha beta as c by a and alpha plus beta as minus b by a into this expression, we will get this as a result. Now, we need to solve it by taking the LCM and solving it. We get the final expression as 3abc minus b cube upon a cube. I suggest you to practicize these numericals, these questions, so as to have the better understanding, and many more questions are given into your self-learning material, where you can exercise those questions, and you will have a better grip onto the subject, that how to determine the roots of the equation, how the roots of equations are used to determine solution of the identities likewise discussed over here. Now, the important question is about the finding of the quadratic equation when the roots are known to you. In the beginning, we already discussed that what was the purpose of finding the roots of the equation. And if the quadratic equation is not given to you, but the roots of the equation are given to you, then by simply using the roots of the equation, you can find the quadratic equation. That means you can reverse the process. And to reverse the process, the formula which is used is x square minus sum of roots into x plus product of roots is equal to 0. This will be our resulting quadratic equation. Now, over here the example is that find the quadratic equation with the real coefficients and with the following pair of roots. The first pair of roots given to you is 3 by 5 and minus 4 by 3. So, what simply we are supposed to do? We are supposed to firstly find the sum of roots, that is 3 by 5 into plus minus 4 by 3. And on solving this by taking LCM and all those things, this turns out to be minus 11 by 15. On the same lines, the product of roots is to be calculated, wherein 3 by 5 is to be multiplied by minus 4 by 3, and by calculation you will find that 3 is cancelled by 3 and you will be getting the answer minus 4 by 5. Hence, substituting the sum of products and sum of roots and the product of roots at their respective position, that is this place and at this place in this equation, you will find that the resulting quadratic equation is x square minus of 11 by 15 plus minus of 4 by 5. Now, solving this entire equation, minus and minus will cancel out and this minus will exist. So, 15x square plus 11x minus 12 is equal to 0 will be the resulting quadratic equation. So, I hope you understood that by knowing simply the roots, we can find the quadratic equation. On the same lines, say for the next question, say 1 plus square root of 3 and 1 minus square root of 3 are the two roots of the quadratic equation. Then and we don't know what the quadratic equation is. Say the general form of the quadratic equation is ax square plus bx plus c is equal to 0, and we don't know what is a, what is b, and what is c. Then in order to formulate the quadratic equation, firstly we need to find the sum of the roots, that is 1 plus square root of 3 plus 1 minus square root of 3. So, 3 and 3 will cancel out and 1 plus 1 is 2. Similarly, the product of square roots, that is 1 plus square root of 3 into 1 minus square root of 3. Now, we are using the identity a square minus b square is equal to a plus b into a minus b. Now, using this identity into this expression, what you will get, it is 1 minus 3, that is minus 2. Now, substituting 2 and minus 2 into this expression, that is x square minus sum of roots into x plus product of roots, that is you will get x square minus 2x minus 2 equal to 0. So, I hope you understood how to determine the quadratic equation when the roots are already given to you. Similarly, we can find, let's move on to some more questions so as to have the better understanding. Now, over here the question is that the two roots r1 and r2 of the quadratic equation x square plus kx plus 12 is equal to 0 are such that the modulus of r1 minus r2 is equal to 1, and we are supposed to find k. We are not aware of what k is. So, we already understood that if roots are given to you and you are supposed to formulate the quadratic equation, then the procedure is x square minus sum of roots into x plus product of roots is equal to 0. And we know that the sum of roots is minus b by a and product of roots is c by a. Now, we are given that if we have r1 plus r2 is equal to k. So, two roots r1 and r2 of the quadratic equation x square plus kx plus 12 equal to 0. Now, sum of roots, because r1 and r2 are the sum of roots. So, this is minus k, okay, because a is how we are getting it, r1 plus r2 will be equal to minus of b by a. We know that this, say this is alpha and say this is beta. So, alpha plus beta is equal to minus of b by a. What is b in this equation? What is b in this equation? B is nothing but k. So, minus of k, and what is a? A is nothing but 1. So, minus k upon 1. So, that means r1 plus r2 is equal to minus of k. I hope you understood how we got this expression r1 plus r2 is equal to minus k. Similarly, r1 into r2 is c by a. Now, in this equation, what is the value of c? C is 12, and what is the coefficient a is 1. So, r1 into r2 is nothing but 12. So, this is how we get r1 into r2 is equal to 12 and r1 plus r2 is equal to minus k. Now, we are given that our modulus of r1 minus r2 is equal to 1. So, that means, just wait. So, that means r1 minus r2, we are given r1 minus r2 is equal to 1, this is given over here into the expression. So, that means r1 minus r2 square is nothing but 1 square, which is nothing but 1. And we can always write r1 minus r2 square, r1 minus r2 square as r1 plus r2 square minus 4 r1 r2. How? because R1 plus R2 square is R1 plus R2 using the identity A plus B square, which is equal to A square plus B square plus 2AB. Over here in this expression, you will get R1 square plus R2 square plus 2R1 R2 minus of 4R1 R2. Because of this, 2R1 R2 will be adjusted with minus 4R1 R2, and you will be having expression R1 square plus R2 square minus 2R1 R2, and which is nothing but the formula for A minus B square, that is A square plus B square minus 2AB. So that means R1 minus R2 square, this is the identity, and can always be written in the form R1 minus R2 square is equal to R1 plus R2 square minus 4R1 R2. So we got this expression, that is R1 minus R2 square, which is nothing but square of 1 only. So this is equal to 1, and which is nothing but can be expressed as R1 plus R2 whole square minus 4R1 R2. And we had already calculated that R1 plus R2 is nothing but minus of k, and R1 into R2 is nothing but, R1 into R2 is nothing but 12. So substituting the value of R1 and R2, R1 into R2 and R1 plus R2 into this expressions, you will get minus of k square minus 4 into 12, which is nothing but k square into 12 for the 48. So this is the expression. Now this is equal to 1. So this implies k square minus 48 is equal to 1. That means by rearranging the equation, you can get, by taking 48 onto the left hand side, you can get k square is equal to 49, and taking the square root of the both sides, you will get k is equal to plus minus 7. So the value of k is nothing but plus minus 7. I hope you understood what the numerical is all about and how you can apply the concept to find the specific coefficient also by using this mechanism. Now, to have better understanding, to a further level of extent, let me solve one more example, and this will give you a better insight. And the example is the sum of the squares of the two numbers is 233, and one of the number is 3 less than twice the other. Find the numbers. So you just read the statement. Since one number is 3 less than twice the other, then we can combine that. Say if one number is x, then second number is 3 less than the twice of the other number. So that means 2x minus 3. What is the twice of the number? 2x. If the number is x, the twice of the number is 2x. 3 less than, so 2x minus 3 is the other number. And it is said that sum of the squares of the two numbers is 233. So the square of their two numbers are 2x minus 3 and x. So sum of the squares, that means x square plus 2x minus 3 square, and this turns out to be 233. I hope you understood how we formulate this equation. Now this is a word problem, and we are using the concept which we learned till the moment to solve such type of problems, that we are supposed to find the numbers. So in all, if we again apply the entity a minus b square over here, then we are getting a square plus b square minus 2ab. So expanding this expression, we are getting this, and rearranging this equation, so we will get x square plus 2x square is 4x square, plus 3 square is 9, and 2ab, so 3 to the 6 to the 12, so 12x, and 233 is taken on this side. So we are getting a perfect quadratic equation, which is 5x square minus 12x, because 4x square plus x square turns out to be 5x square. We are having 12x as the second value, and 9 plus 233 plus 9 minus 233 turns out to be minus 224. Now, this is the quadratic equation. Now, using the quadratic formula, that is minus b plus minus b square minus 4ac upon 2a, you will get the root values. So, this turns out to be that x is equal to this. So, on calculating, you will find that x, you are having two roots, that is 8 or minus 28 by 3. Now, the point to be noted is that d value, that is b square minus 4ac, is greater than 0. That is why the roots are real. Roots are real. So, we are having when x is equal to 8, when one of the root is x is equal to 8, then the two numbers are, so first number was x, so x was equal to 8, and other number was 3 less than twice of the first number. So, 2x minus 3 was the next number. So, that means 2 into 8 minus 3. So, the next number was 13. So, I hope you understood how we got x and the say we can say x1 and x2 is equal to the other number is 13. Similarly, when x is equal to minus 28 by 5, that is the other root, you can calculate that the other number is twice of minus 28 by 5 minus 3, that turns out to be minus 71 upon 5. So, this is one of the problem, and let us solve one more type of problem, and this problem is, if alpha and beta are the roots of the equation 2x square minus 3x minus 5 is equal to 0, form a quadratic equation whose roots are alpha square and beta square. Now, we know that if we know the roots of the equation, that is alpha and beta, then we can formulate the quadratic equation by using the expression x square minus alpha plus beta into x plus alpha beta is equal to 0, wherein alpha plus beta is equal to minus b by a and alpha beta is equal to c by a, where a, b, c are the coefficients of the quadratic equation ax square plus bx plus c equal to 0. Now, since alpha and beta are the roots of the quadratic equation 2x square minus 3x minus 5. So, applying these identities, that is alpha plus beta is equal to minus b by a, we will get that alpha plus beta is equal to minus of 3 by 2, because coefficient of x square, that is a, is 2 and this is minus 3. So, minus of minus b by a. So, what is b is minus 3. So, 3 by 2 will turn out to be alpha plus beta, and alpha beta turns out to be c by a, and c is nothing but minus 5. So, minus 5 by 2 turns out to be alpha beta. Now, what we are expected to perform? We are expected to form a quadratic equation whose roots are alpha square and beta square. So, we are supposed to firstly find the sum of roots and the product of roots, whose roots are alpha square and beta square. So, sum of alpha square plus beta square, as we earlier did, alpha square plus beta square can be expressed as alpha plus beta square minus 2 alpha beta. How? We are using the identity a plus b whole square is equal to a square plus b square plus 2ab. That means a square plus b square is equal to a plus b whole square minus 2ab. So, that means we got alpha plus beta whole square minus 2 alpha beta, and we already know that alpha plus beta is 3 by 2. So, substituting 3 by 2 in place of alpha plus beta and substituting minus 5 by 12 in place of alpha beta, you will get 5 by 2 in place of alpha beta, you will get the final answer as 29 by 4, which you will get for the sum of the roots. Similarly, the product of the roots will be alpha square into beta square. Now, alpha square into beta square can be represented as alpha into beta whole square, and we already know that alpha into beta is minus 5 by 2. So, minus 5 by 2 whole square, this turns out to be 25 by 4. Now, substituting the sum of products and the product of roots, sum of roots and the product of roots into this expression, that means x square minus sum of roots into x plus product of roots, you will get s, replace s by 29 by 4 and p by 25 by 4, you will get the quadratic equation x square minus 29 by 4x plus 25 by 4. Now, again solving this, simplifying the expression, you will get the quadratic equation 4x square minus 29x plus 25. This is the quadratic equation for which the roots are alpha square and beta square. And this is a very important question, and try to exercise more and more questions given into your study material, and you will really feel confident about the quadratic equations, and you will perform better in your examinations, be it term end examinations or the continuous evaluation be there. And I suggest you to refer to your self-learning material in a continuous manner, and just by watching these sessions, you will not be able to attempt the numericals in your examinations. So, I suggest you to have more and more practice along with the watching of these videos. Just go through the SLMs also, self-learning materials. Thank you very much.